Assalamu alaikum dear students. Okay, so after finishing respiration and its phases, there were three phases of the aerobic respiration. Okay, so they were glycolysis, and then in glycolysis glucose was converted into this glucose was converted into two molecules of pyruvic acid, and then this pyruvic acid was oxidatively decarboxylated to pyruvate to acetyl coenzyme A. And then that acetyl coenzyme A was fed into Krebs cycle, the second stage of respiration. Aerobic respiration is Krebs cycle, and in Krebs cycle, as you saw, that we get ATP and NADH2 and one molecule of FADH. So all these things, NADH and FADH, they are put in electron transport chain, where we get ultimately through oxidative phosphorylation, and we get ATP. That is the third phase of this aerobic respiration, was electron transport chain. So after that, I explained already about this the stoichiometry, or the summary of ATP, total molecules of ATP produced per glucose molecule, and we saw that it is actually 36 ATP molecules. In some cases it is actually 38 molecules. Okay, so we say it is 36 or 38 molecules per glucose molecule. That means when one glucose molecule gets oxidized through aerobic respiration, we get 36 to 38 molecules of ATP. Now there is one more topic about this respiration, and that is respiratory quotient. So what is respiratory quotient? Respiratory quotient states that it is the ratio of volume of carbon dioxide produced to the volume of oxygen consumed. That means respiratory quotient, RQ, is equal to carbon dioxide release, the volume of carbon dioxide release, and over the volume of oxygen consumed. So there are certain functions, because already you know that in case of respiration, this oxygen gets used up, and this carbon dioxide is released. So it is simply the ratio between volume of carbon dioxide released and the volume of oxygen consumed. How many moles of oxygen are consumed, and then how many moles of this carbon dioxide are released. So this is respiratory quotient. It has certain functions. It states that it calculates the quantity of oxygen consumed and quantity of carbon dioxide released, and we get this by applying this respiratory quotient. So the respiratory quotient also represents the oxidation reactions of various kinds of food or substrates. Means there are number of substrates for respiration. As I already told you, there may be this glucose, that means carbohydrates, fats, proteins. Okay, so these are the different substrates of this respiration. It also reflects the metabolic rate of an organism. So the respiratory quotient of most animals at rest, if the animals are at rest, their respiratory quotient ranges from 0.8 to 9. That means if they are at rest, it means that either their fat or protein is being used as a respiratory substrate. And the human RQ is about to 0.85. So human respiratory quotient is around 0.85. That means normally it is 0.85. These are the respiratory quotient for different or common types of foods. You can see here glucose. The equation is C6H12O6 plus 6 times oxygen it is consumed, and 6 molecules of carbon dioxide released. So 6 by 6 means 1. That means for glucose the respiratory quotient is 1. Similarly for fats like palmitic acid, here 23 oxygen molecules are consumed and only 16 carbon dioxide are released. So it means 0.696. It is the respiratory quotient for fats like palmitic acid. And for proteins, the example is albumin. So 77 oxygen molecules are used and 63 molecules are released. That means 0.8. And for proteins, the respiratory quotient is 0.8. There is next thing. This is the type of substance is being metabolized. So here it is shown the seed as an example. So during different stages of seed growth and development, when a seed germinates, what are the different stages of the seed germination and how much RQ does it have? So here this graph suggests that the seed begins with carbohydrate as metabolite. Okay, so whenever seed it starts to germinate, it uses carbon dioxide as the food. So then after first stage, this substrate changes to fat or oil, then it returns again to carbohydrates. Okay, so here RQ has this has different types for different respiration types. Okay, it is different. RQ is different for different respiration types. What is here is if RQ is less than 1, that means it is aerobic respiration taking place. If RQ is equal to 1, again aerobic respiration. If RQ is greater than 1, that means it is anaerobic respiration. So the low value of RQ, okay, here you can see here the low value of RQ, it indicates that different यहाँ पे हमें बहुत सारे ऑप्शंस है कि जब लो RQ होगा तो इसका मतलब बहुत सारे मतलब निकलते हैं. तो पहला मतलब क्या है कि जब लो RQ होगा, लेस देन 1 होगा, तो इसका मतलब है कि एरोबिक रेस्पिरेशन हो रही है. और उससे दूसरा पॉइंट क्या है कि इसी के साथ ये भी पता चलता है कि प्लांट्स एब्जॉर्ब कार्बन डाइऑक्साइड टू कैरी आउट फोटोसिंथेसिस, प्लांट्स में फोटोसिंथेसिस भी हो रही है उस टाइम पे. और एनिमल्स क्या हो रहे हैं, वो यूटिलाइज कार्बन कर रहे हैं क्या बनाने के लिए, अपनी जो कैल्शियम शेल्स होती है, मोलस्कस में होती है, स्नेल्स में होती है, तो उनमें वो बनाने के लिए ये यूज़ कार्बन कर रहे हैं, कार्बन स्केलेटन बना रहे हैं. ठीक है ना, कि जब लो RQ होगा, रेस्पिरेटरी कोशेंट जब लेस देन 1 होगा, तो इसका मतलब ये है. और जब हाई RQ होगा, when the RQ is greater than 1, it indicates that anaerobic respiration is being carried out. And then this conversion of carbohydrates into fats, example. So जब हाइबरनेशन होती है तो क्या हो रहा है वहाँ पे, कार्बोहाइड्रेट्स को फैट्स में कन्वर्ट किया जाता है. और जब आप लोग ये भी देखते हो कि जब हाई RQ होगा, ग्रेटर देन 1 होगा, तो इसका मतलब ये भी है कि इसके साथ क्या हो रहा है, कन्वर्जन प्रोसेस ऑफ लार्ज क्वांटिटी ऑफ फूड फॉर स्टोरेज. तो फूड स्टोरेज के लिए यहाँ पे हो रहा है कि जैसे ग्लूकोज को कन्वर्ट कर रहे हैं स्टार्च में, जैसे प्लांट्स में स्टार्च होता है, एनिमल्स में ग्लाइकोजन होता है, फूड स्टोरेज. सो जब ये हाई RQ का ग्रेटर देन 1 होगा, तो इसका मतलब ये होता है. सो दिस इज़ ऑल अबाउट दिस respiratory quotient. Tomorrow we are going to talk about nitrogen metabolism. Thank you.